In this lecture, we will going to talk about the key points of a number-based conversion.
So the key point is that whatever the base radix you want to convert, whatever the number, given number, let's say this is the given number and this is your base radix. So let's say this, I'm saying this is a base radix. So what you have to do in general, you have to divide that number. What will be the number you have got? You have to divide it by the value r. You got this concept? Whatever the conversion is given to you in an examination, you can convert it with the simple process. Till now we have talked about is the integer part only, that is integer part. But when we are talking about the decimal number, we do not say we are only talking about the integer part. We have got a fraction part also. So whenever we are talking about the decimal number, we say the decimal number is being formed with the help of integer part plus fractional part. The integer part, whenever we want to convert the number into the integer part, what we have done, we have divided this part with the base radix r. So if I have to convert this fractional part into the given radix, what can be my approach? We have to multiply. So why we are multiplying? Can you tell me why? Is there any reason that we have to multiply, or we have studied this that we have to multiply, that's why we are multiplying it? The question is how you are obtaining the fractional part. So whenever we are saying fractional part, so let's take an example. What we are saying that suppose we have got this 1.5. So what this 1.5 means, that this is having a power of, as you have said, it is mean multiplying with the base. Okay, so whatever you are having, you are multiplying. When we are talking about this 0.5, so why we are getting this 0.5? We are getting this 0.5 because we are dividing. Let's say we have got a numerator and denominator. So what you can see that whenever our numerator is greater than the denominator, you will not going to get decimal part. Whenever your numerator is less than this denominator, for example, if I'm saying 1 divided by 2, so you can see that this numerator is being smaller than this denominator. So answer will be your 0.5. And if I take another example, let's say numerator is, let's say 4 divided by 2. So what will be my answer? My answer will be, let's say 2. So what we are doing, when we are converting it into the other radix, so what we have got, if we have got this part, that is means the integer part plus fractional part. So in this integer part, if we want to convert into the base r, what we are doing, we are dividing the number and we will going to do the reciprocal of this. So what we have to do, we have to multiply the number. Okay, so it's clear to you why we are going for the multiplication? Because we want to make it into the integer format. So let's say if I have 0.5 and if I divide it, again I will get answer in, let's say 0.25. Okay, I cannot make it into the integer format. But if I have a 0.5 and I will going to make it multiply by 2, I will get 1.0. So what I have done, I have make it into a integer format. This is the approach which we are using in the digital electronics. Whatever the components you are using the digital electronics, so we have to make the decimal point equivalent to the integer part. So therefore we are going for the multiplication. Suppose I have got an example that 0.6875 and I want to convert this decimal into the binary. So what I will going to do is that I will going to take this number. So again I will going to follow the same procedure that in which I have to convert this 0.6875 into the base of 2, and you know the base of 2 have either 0 or 1. So what we will going to do, we will going to multiply it by the base 2. How we can write? 0.6875 multiplied by 2. Again what we will be getting? We will be getting the integer part plus fraction part. So I will be writing here I integer and I writing a fraction part, and then I will going to write a coefficient part. So can you tell me what is 0.68752 will going to give you? It will going to give you, let's say 1.3750. 1.3750. So what will be my integer part? My integer part will be 1 and my fraction part will be 375. So what will be my coefficient right now? My coefficient will be, now you will going to do the reciprocal of it. So you will going to take a remainder, or we can say the coefficient from the integer part. So this will be your a minus 1. Okay, this will be your a minus 1, and a minus 1 is your 1. Then what you will going to do? You will going to take this number 0.3750 multiply by 2. What will be the answer? It will going to give you 0.750. So what will be the integer part? 0 and 0.750. So this is will be your a minus 2, and this will be your 0. Then take this 0.750 here, take this 7.50 here, 0.750 multiply by 2. What will be your answer? So you will be getting 1.500. So let's say I will be getting 1 and I will be writing 50. So I will going to take this a minus 3 equal to 0. Sorry, 1. Then what I will going to do? I will going to take this 0.500 multiply by 2. What I will be getting? I will be getting 1.00. So I will be writing here 1 and 0.00. My a minus 4 will be equal to 1. So now the question is, how long? Suppose we have got this 0 here. Okay, we have got this 0. So maybe in some of the example you can find that when you are doing the multiplication of a number, you are not getting the 0. You are not getting this last part. All the digits are becoming 0. Okay, maybe there can be some numbers where you will not going to find this always 0. In that case, what you have to do? You have to obtain your result till you are getting the accuracy of a digit. So let's say if the number is repeating again and again, so when we are saying that how much accuracy you want, so generally when we are talking about the decimal points, so what we can say, if you are taking some readings, let's say if you are taking the reading of a oil or a reading of a liquid, so you can obtain your result till 4 decimal points or 2 decimal points. If you are going for the more smaller particle reading, after point you will require 10 decimal places. Okay, so example, if you are measuring the weight of a molecules to measure the accurate volume or the weight of that molecule. I think this you have studied in your chemistry. How we will going to write it? A5, A4, A3, A2, A1, A0, and then dot, then A minus 1, A minus 2, A minus 3, A minus 4. So your answer will be starting from 1, 0, 1, 1. So this is your A minus 1. So always you are, when you are going for the fractional part, you have to move from top to bottom. Okay, so your answer will be 0.1011. Now suppose if we have a number in which we have got both integer part and the decimal part, so what do you have to do? Okay, so suppose let's say if I have got a number like this, 41.6875. Let's say this was the decimal and I want to convert into the binary. So what you have to do? You have to break this number. You have whatever the number you have given, you have to break this number into the integer part and the fraction part. So this 41.687, you can write this in this form. Okay, how? 41 plus 0.6875. Now what you have to do? You have to do the calculation on this 41. How? 41 divided by 2, like this. And what you have to do the calculation on this 0.6875 multiplied by 2. So whatever the result you obtain here, so let me see what was our previous result. So 0.101, so I can write here 0.1011. And what was the 41? What number we have got result? That was 101001. What was the answer? 101001. This was the answer. So what do you have to do? You have to, as we have seen that, we have to simply add it. Okay, so how we will going to add it? We will going to write this number like this: 10100 1 point, let's say if I'm taking 4 digits, 0 0 0, I can write this in this way, and then 1 0 1 1. What I'm doing, I'm doing simple addition. So what will be my answer? 1 1 0 1 1 0 0 1 0 1. Answer. When we are going for the digital electronics, what we have to do, we have to do the addition, subtraction and the multiplication in it. Okay, so we have to see how we are going to perform the addition, subtraction and multiplication in it. Okay, so now we will going to discuss about the arithmetic operations that can be done on these numbers. Whenever we are talking about the arithmetic operations, we have got two approaches. Approaches means that whenever we are adding two numbers, let's talk about additions first. So let's say one of the operation which we are performing is the addition. Okay, so whenever we are talking about the addition of two numbers, we have got a augend and the addend. Means one number in which we have to add. Okay, the number in which we have to add is called as the augend, and the number which is to be added is known as the addend. Okay, so what we can say, that we have got a name augend, and the number which has to be added is known as the addend, and the addition of this what we are getting is known as the sum. Yes, I'm just repeating. So the augend is the number in which you will going to do the addition, and addend is the number by which you are doing the addition. Okay, for example, let's take an example first. Let's say if I have got a 5, and let's say I'm making here 4. So what is my 5? I have a number 5, and what I'm doing, I'm adding a number 4 in it. Okay, so 5 plus 4 will going to give you me a sum of 9. Okay, I will get a sum of 9. So 5 will be my augend, and 4 will be my addend, and 9 will be my sum. So whenever you are going for the digital electronics, you will going to find this terminology. Suppose in a question it has been asked that you have been given an augend and you have an addend. So you have to understand why we are making this difference. You will going to find this important when you go for the addition in the digital electronics. That what is the importance of this augend and the addend when you will going to perform the addition in the digital electronics. So we will going to come to that also. So let's say I'm having an augend as 1 0 1 1 0 1. Can you tell me what is the decimal equivalent of this? The decimal equivalent of this is 45. So how you have calculated? Simply you have written it as 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. And suppose I have an addend like 1 0 0 1 1 1. So can you what will be the answer of this? 39. So let's say I have got a 39. So if I add this 39 plus 45, what will be my answer? 9 plus 5 14, 4 plus 3 7, 7 plus 1 8, 84. So when I am doing this calculation of this number, I should get the 84 decimal number equivalent of a 84. So how can I do the addition? So to perform the addition, we have got a general rule. Okay, so what is the general rule say? That whenever you are performing the addition, so when we are saying that when we have a number, we can have a number either 0 or 1. So what we have to do when we are doing the addition of any number, let's say 0 plus 0, what will be my answer? I will get a 0. Okay, I can have a 0 plus 1. What will be my answer? 0 plus 1 is 1. Okay, I have 1 plus 0, then I have an answer again 1. But if I have 1 plus 1, what will be my answer? 1 plus 1 is 1. Okay, but actually 1 plus 1 is not 1. 1 plus 1 will going to make it 10. So what will it will going to do, because after 0 and 1 we have to move into the second point. That is, after 1, suppose we have got a 0 and 1. Okay, so 0 and 1. After 0 and 1, what we will going to do, we will going to add a 1 to it. It will going to make us 1. So 1 plus 1 will going to make our number. That's it, 10. Okay, I'm just explaining this because this is very important. So 10, I will obtain this 10, but how much bit I can store? I can store only 1 bit. So what it will going to do is that it will going to store this number. It will going to store this number here. Okay, so I will get 1 plus 1 as a 0. Okay, and it will going to make it as a carry. Carry will going go to the second place. It will going to move to the second position of the number. So let's say if I talk about this number, what will my 1 plus 1? It will going to give me a 10. So I will going to have a 0 here, and let me remove this one first. What will be my carry? My carry will be 1. Then again I will going to do 1 plus 0. 1 plus 0 is 1, and 1 plus 1 is again 10. So what I will get? I will get a 0 here, and I will going to add a carry here. Okay, 1 plus 1. Again 1 plus 1 is 10. 1 plus 1 is 10. So again if I get like this, 1 plus 1 plus 1. So what I will do? I will going to do 1 plus 1 is 10. I will going to take this. This will move into the carry one. I will forget this. I will make it as a carry, and then 0 plus 1. I will going to add 0 plus 1 will going to 1. So I will get 1 here with carry. That means I will going to get 10 plus 1. Answer is your 11. You are getting this point? 10 plus 1 will going to give you 11. So I will going to store 1 here, and 1 will go into the carry. So again 1 plus 1 will going to take you 0. Okay, 1 plus 1 will going to take you 0, and here 1 comes. 1 plus 0 give you 1, and 1 plus 1 there will be no carry, so 0 will be carry. So 1 plus 1 will going to give you 10. And now if you do the calculation of it, just check whether you are getting 84 or not. So this is the operation which we are doing in the addition. This is known as the addition operation. In the next class we will going to see the subtraction and the multiplication. That's all. So thank you everyone.